the input is accepted, if the input is accepted, comma, it follows that all crossing sequences are of odd length. All crossing sequences are of odd length. So is it there in this crossing sequences? Just verify this point from the crossing sequences example. Right? Next point, a crossing sequence Q1, Q2 up to Qk is said to be valid if it is of odd length, comma, and no two odd or two even numbered elements are identical. Full stop. A 2DFA with S states, small s, S states can have valid crossing sequences of length at most 2s, comma, so the number of valid crossing sequences is finite. So clear? All the points are clear? Another important observation about crossing sequences is that the first time a boundary is crossed. So first time we are crossing the boundary, so it is the head must be moving towards right. Then yes, subsequent crosses must represent right moves and alternate right and left. And then odd numbered elements. So this is the odd number element, this is even number element. So odd number elements of crossing sequence right moves, even number represents left moves. And if the input is accepted, it follows all crossing sequences are of odd length. So either 1 is there or 3 is there. Right? And this is very important question from the small questions. Which is the valid crossing sequence? Right? To define the crossing sequence. Characteristics of the crossing sequence. Right? So this type of questions. So we are done with the section A, in which last topic is there applications of finite automata, in which we will be covering two lexical analyzers and text editors. So the theory is there, that is available in the books. So just go through it, how finite automata is helpful in lexical analysis and the text editors. We have just touched upon this topic, that if semicolon is missing or curly braces are not matched, and how it is helpful, finite automata is helpful in these things. So this is lexical analysis. Even in text editors, we have number of problems that whenever we are writing. So how it is able to find the errors in it. Right. So any doubt till section A, that will move forward. So let me know how would you like to move forward. Start with section B. So then we have finite automata with output. So now the finite automata till yet is not giving us the output. It is just telling us whether the input string is accepted or not, right? So here we have the modified version of the finite automata in which we are getting the output as well, right? So two type of variations are there in finite automata with output. One is the Mealy machine, another is the Murray machine. So finite automata with output. So one is the Murray machine and another is the Mealy machine. So we start with the Murray machine. So Murray machine can be defined as 6-tuple definition. And it is explained as capital Q, sigma, delta, small delta, this is delta, this is lambda, this is Q naught. So this is similar to the definition of finite automata with a small difference. Capital Q is same as the finite automata, sigma is same as the finite automata, this delta is transition function is same, this Q node is same. Right. So what is missing over here? F is there. F is not there. Why? Because we are not concerned about the acceptance or rejection of the input string. But here we are finding the output. Right. So two components have been added over here. So what this delta says? Similar to sigma, delta is playing the role. Sigma is for permissible input symbols. And delta is there for permissible output symbols. Which symbols can make the output of this Mealy or Murray machine. And lambda is playing the role similar to delta. Delta is for the transition function that transits from the one state to the another state. So what is lambda? Output function. So how we are getting the output? So this is the terminology. So this lambda is Q maps to delta. Right. So rest of the definitions are same as that of the finite automata. So Q maps to delta. So here the thing is that the output is directly associated with the current state only. It is not looking at the input symbol. But whenever you are coming to one state, it is directly giving the output. Right. So we compare it with okay, differences we'll do that. So in the case of Mealy machine, it is again 6-tuple definition, and it is also represented like we have written for Boolean machine. And here there is a difference only in the output function. And what is the difference? Q Cartesian product sigma maps to some output sigma. So here in the case of the Boolean machine, the output depends upon the current state and the current input symbol. But the Boolean machine, the output is dependent only on the current state. This is the major difference between Boolean and Boolean machine. Second thing, you compare the Mealy and Boolean machine with do while and while do loop. What is the difference over there? So similarly in this case also, in the case of Boolean machine, we start with the state Q node, right? So as we start with Q node, it will directly give the output. But in the case of Boolean machine, you start with Q node, provide some input symbol, it will then give you some output, right? So now again, looking at these concepts, there is one more difference that comes out between Boolean and Boolean machine. On the length of the output string of Boolean and Boolean machine. What is the difference? Whose output string length will be more? Boolean machine. Because as you start at Q node, it gives you the output. Okay? That one character is added over here. But in this case, you will get the length of the input string and output string will be same in the case of Boolean machine. But in the case of Boolean machine, the length of the output string will be one more than the length of the input string. Clear? So then I will just explain, give an example of Mealy and Boolean machine as well. So then we come to what is the equivalence of Mealy and Boolean machine. Mealy and Boolean machine are equivalent to each other. If you have been given a Mealy machine, you can draw the equivalent Boolean machine. If you have been given a Boolean machine, you can draw the equivalent Boolean machine. Right? So now we will do an example how to find the, if you have been given a Boolean machine, how to find the equivalent Boolean machine. So just write down if M1 equal to Q sigma delta lambda and Q node is a Boolean machine, then there is a Boolean machine M2 equivalent to M1. So only thing that we need to map over here is we define M2 as Q sigma delta, again delta, lambda and Q node. So where is the difference between these two? Only this is the difference, right? So, and how to map it? Note down this mathematical formula only, that will help you in converting. Right? So similarly, if we write the reverse of it, you have been given a Boolean machine and you have to convert it to the Boolean machine. So what are the differences over here is, so M1 is a Boolean machine, this is the new definition for if you have been given a Mealy machine, so how to convert it to a Boolean machine. So this is the new definition of Boolean machine. So there is a difference in transition function, there is a difference in output function, difference is there. Even the initial state has been changed to some other symbol. B node, where B node is an arbitrarily selected member of delta. So any output function can be added along with the initial state to make new initial state. So here, so now the states of M2 are defined by the Cartesian product of Q cross sigma. So combination of these two, like capital M comma, we say that Q comma B. B is any input symbol taken from there. So now we define delta dash in this way. So this is a transition function. Okay, we'll take the example from one from each. So have you noted it down? Okay. So which machine is it? Mealy or Boolean? Boolean machine. How?
So because it depends upon current state.
So output is associated only with the state, right? So this is a. So let me know what is the output corresponding to this input string. What is the output corresponding to this string?
Output 1.
0, 1.
0.
1. 7.
This is the output. So is its length is greater than input string? One more, because we are just giving the output as we start with the right? So that's why the length is more. Now we are converting this Boolean machine into Mealy machine. So first what we'll do is we'll draw the transition table for it. Okay, how to draw the transition table corresponding to either Mealy or Murray machines? This is a Murray machine, right? And the output is corresponding to the state.